Hello, welcome to our presentation, and I am going to present our paper named Imagering Hurricane Forecasting Based on Artificial Intelligence, a Systematic Review. The authors are Raquel Pereira de Alcântara, Adalto Tertulino de Freitas Neto, Diogo Nunes de Oliveira, myself, and Eduardo Noronha de Andrade Freitas. This is our agenda. We'll first make a brief introduction to our theme, to our topic, followed by our systematic review process. We're going to explain what we're willing to do in this work. Then we'll move forward to the theoretical background in order to understand what actually motivated our research. And once we present the background, the theoretical background, we move to the results analysis. And finally, we won't be able to on live answer questions, but you can feel free to submit questions, email us with any questions, comments, and or suggestions. And I'll also present our conclusion. So first of all, before we get into what our paper is focusing on, we have to understand what actually motivated our work, why we decided to move forward with this work and present this research, what actually motivated our research. And our research was motivated actually by the introduction itself. So our work is focused on being able to determine or at least analyze efforts that are trying to determine or deploy techniques to determine when a hurricane hit, or we have other types of natural disasters in the same category. So basically we're focusing on tropical cyclones or hurricanes or typhoons. Obviously the nomenclature depends on where they are occurring. But the goal here is to analyze the efforts that the academic environment has been publishing, has been deploying, in order to be able to predict whenever these types of natural disasters or natural events happen. So tropical cyclones, hurricanes, typhoons, when occurred, they can cause devastating material damage and loss of life, making it necessary to develop techniques to mitigate its damage by deploying early warning systems. They're also called EWS. So whenever you see the three-letter acronym EWS and it's associated with natural disasters, most of the times they're associated with natural disasters. These are early warning systems. Obviously, we do have EWS systems for other types of disasters, even man-made disasters such as cyber attacks. But most of the times, when you hear EWS, early warning systems, they will be associated with natural disasters. So whenever these events occur, whenever these hits occur, and there is the chance that damages financial and life losses occur, we want to create techniques, develop techniques to at least reduce the damage of those hits. So again, by deploying EWS systems, but still, even with EWS systems, there is still a chance that they occur, and therefore we need to measure the intensity of the threat. So systems are being developed to measure the intensity of those threats as well. And ideally, not only measure the intensity, but also determine the respective trajectory, if that's possible. So, especially in areas where these events are very common. For example, in the United States, it's very common to see hurricanes in the Gulf Bay, basically in the southeast area of the country. It's common to see tornadoes in the Midwest. So depending on the area, you want to determine what type of natural disaster that's gonna happen, but also the trajectory. So you want to be able to beforehand tell where it's gonna go through. And as artificial intelligence techniques evolve, more resources are made available to help specialists understand and create strategies to reduce the damage that might be caused by these natural phenomena. Now, a large limitation in the advancement of studies related to hurricane forecasting is linked to the fact that part of the work is still manual, with the models not being fully automated. Now, observe that we're not stating here that the entire solutions, most of the solutions are basically manual, but a good portion, or at least some portion of these techniques are manual. They are not fully automated, which is a big problem because there is such a complexity involved in determining, for example, the intensity and mostly the trajectory that is going to be taken by those events. Therefore, one of the great challenges of studies related to hurricane forecasting is to modify existing machine learning techniques to improve results. Now, obviously, not only machine learning techniques, all kinds of techniques, but machine learning techniques are they're being widely adopted to implement these types of predictive models. Okay, now, as far as our review, the systematic review process that we deployed can be basically divided into three parts. We have our objective. We want to answer these research questions, and in order to answer those research questions, we have some metrics or a couple of metrics. So the objective, as previously stated, is to investigate hurricane forecasting techniques which explores the use of images and prediction models based on artificial intelligence. So yes, we are focusing on artificial intelligence and on techniques that use images to deploy these prediction models, to implement these prediction models. We're going to see that whenever we say that we want to explore images, it's not the image itself, but the characteristics associated with those images. We'll get to that in a few minutes. Okay, so from our objective, we have a couple of research questions that we'd like to answer. So the first research question is, which are the main variables used to predict trajectory and/or intensity of hurricanes? So as you may know, there are so many different variables that can be analyzed in order to try to predict the trajectory of a hurricane. Just like anything else in life, you can have several different variables to be analyzed, but it depends on the study, it depends on the situation, it may depend on a number of factors in order to define what variables you're going to use. So for example, you may have the speed, the wind speed. You may analyze the latitude, longitude. You may analyze the area. You may analyze, if we're considering a hurricane, you may analyze how dense or how sparse the eye of the hurricane is. So the metrics associated with this question is analyze the used variables in hurricane forecasting techniques. Now, our second research question is, which techniques based on artificial intelligence exploring the use of images have been adopted in forecasting the trajectory and or intensity of hurricanes? So we want to be able to determine the actual techniques or algorithms that are being used by the academic embodiment to determine to answer these questions. So the techniques used in hurricane forecasting. Okay, now how did we analyze these studies, the existing studies? Okay, so first of all, we selected a few digital libraries. In this case, we selected ACM, IEEE, Scopus, and Springer. So those are the digital libraries that we selected. And once we determined those digital libraries, we started our phase one, which was the database search. So in this database search, what we did was to determine a few strings or substrings to find papers, to find efforts, to find studies associated with our topic, which is, for example, hurricane imaging or imaging for prediction, or artificial intelligence for prediction, or hurricane artificial intelligence. So we created a broad number of strings that we used in order to perform this search. Okay, out of that phase, we found 153 papers. As you can see here at the top, you can see that from ACM we got 51 hits, IEEE 20, Scopus 33, and Springer 49. Okay, now out of those 153, 17 were duplicated, so we reduced that to 136. In phase two, we performed the selection of studies by reading the title and the abstract, just to make sure that we were not only selecting papers based on the title that may mislead us. So we wanted to make sure that we were selecting papers, titles that were actually associated with what we wanted. So from that, we saw that 100 of those were not what we expected, so we filtered down to 36 papers. And then we went to phase 3, where we performed the full reading and data extraction. Now, as far as the theoretical background, in order to improve the predictability of hurricanes, both in terms of trajectory and intensity, several models have been presented in the literature. And when we say in the literature, remember that we're referring to those 36, specifically those 36 papers, using different approaches, such as those ones that are, so we have these broad areas, such as statistical models. We also have the numerical methods, machine learning, which is basically a sub-area of artificial intelligence, and we can have a combination of those three other models or approaches. Okay, now as far as the differentiation between those three models, the statistical model is a model based on historical observation and meteorological characteristics. We also have the numerical methods or models that are dynamic models that seek or try to represent complex physical phenomena in mathematical equations. So basically, in this type of study, what the researchers are doing are using the actual physical and physics of the phenomena in order to deploy a mathematical equation, and by doing that, they should be able to determine, or at least they strive, or at least they try to determine when a hurricane hit is going to happen, or at least determine the trajectory or intensity of that hit. We also have those works that are based on artificial intelligence that use various machine learning techniques in predicting tropical cyclone modeling, or hurricane, if you will. Now, we focused on machine learning due to the number of efforts and due to the promises of the results deployed by these techniques. So recently, many machine learning techniques have been deployed with a great capacity to overcome the current state of the art, especially the convolutional neural networks, or CNNs. And basically, CNNs, or convolutional neural networks, are neural networks with several layers, and were inspired by the mechanism of the optical system of living beings. Now, if you've ever studied neural networks, artificial neural networks, there is a very high probability that we studied perceptron and a multi-layer perceptron. And basically, a CNN is a fork of multi-layer perceptron. It's an implementation of an artificial neural network with several layers. The use of artificial neural networks, especially the learning-based deep networks, gained special attention and has since been used in different contexts, promoting significant advances, which is what motivated our study. That's why we are not only focusing on reviewing efforts in predicting hurricanes, but focusing on efforts trying to predict hurricanes using machine learning. Particularly in the context of forecasting hurricane trajectories and intensity, the use of deep learning has been encouraged mainly by combining characteristics extracted from satellite image databases with diverse historical data, such as I stated before, these image databases are not used to read the images themselves, but the data of these images, such as latitude, longitude, wind speed, speed of change, direction in degrees of the hurricane, and so many others. As I mentioned earlier, the size of the eye of the hurricane, for example. Okay, now, we divided the studies that we analyzed in different categories. Where that study was conducted, the year it's been conducted, the model target, techniques used, variables determined, and the data sources, where they extracted the data that they used in order to deploy that study. So, Focusing on the countries. Now, observe that the here in the result analysis according to countries, it's not these studies were not analyzing where the hurricane hits occurred, but it's the country where the study was conducted. And we can see that by far China was the country that published more efforts in this regard, followed by the United States, then Korea, we have the United Kingdom, the Philippines, Indonesia, Hong Kong, India, and Singapore. Now, we can see here that we don't see a pattern, which is fine, especially if we consider the number of academic researchers that we have in these countries. So basically, this follows the pattern of the number of researchers. Then we have when these efforts were published, when these studies were conducted. So we have most of them being conducted in 2019, then followed by 2020, then 2018, then 2019. We have a few in 2021, which is actually, it makes sense since 2020 is still going. It's still the current year. Then we have 28, 27, 24, 1999. Now, we can clearly observe that this became a more recent concern, although the hurricane hits are not new, and deep learning is not a new technique either. However, it did become a concern more recently. Now, as far as the model target, which is what they are trying to determine, we can see that by far we have intensity ahead of the other targets by far. So out of those 33 papers, we have about 22 that were trying to determine the intensity, then the occurrence in 4 of those efforts, or 3 or 4 of those efforts, just like trajectory, and then we have the typhoon eye detection, the combination of occurrence, typhoon eye detection, the combination of intensity and occurrence, and the combination of intensity, typhoon eye detection. Okay, what we can tell from this analysis is that most of these studies are focused on the intensity of those natural disasters. As far as the techniques, we have the fully connected layers, which is the convolutional neural network, followed by many different techniques. But we can see that convolutional neural networks are far ahead compared to the other techniques. As far as variables go, we have actually balance in the selection of the variables used in those models. So IR images, about 11 of those papers used IR images as its variables. Wind speed was also used and satellite images were also used in many of those. Then we have a balance between the other variables. Now we can see that others are also being used in all of those papers, which means that we cannot determine a criteria when selecting variables to determine trajectory and intensity. And this is a concern. if we don't see pattern when selecting variables, that means that the results of those techniques or predictions will differ a lot, because as you may know, in deep learning, in machine learning, in artificial intelligence, determining the variables is, if not the most one of the most important phases in order to create those prediction models. As far as data sources, where those data were gotten from, where they got the data, once again, you can see that there is no pattern, which is also another big concern. You see, if we have several efforts being conducted, but there is no agreement upon where they will get those data from, we cannot compare these efforts. We cannot, we're not able to tell which method, which algorithm, which model works better, because they're getting data from different sources. Even if they are associated with the same hits, the same natural disasters, which is not very likely, but even still, if that's still the case, we don't know if the data is going to be the same. Therefore, even if the variables, the definition of variables are the same, the output, the result, is going to be different. More likely, they're going to present different results. So in this review that we performed, we could see that although there are a few efforts in order to use artificial intelligence to determine trajectory and intensity of hurricane or cyclone hits, we can't find a standard, we can't find a pattern, which means that we cannot rely too much on the results, because we have different techniques, different algorithms, different variables, different data sources. Each study determines different metrics in order to conduct those studies. So in order to have a reliable, sustainable model to predict the trajectory and intensity of hurricane hits, we must have some kind of standard, we must have some kind of patterns, so that one effort helps the other. These studies should walk together, they should move along together in order to achieve a reliable result, so that the community can implement those techniques in a reliable way. Thank you for watching our presentation, and please, if you have any questions, comments, please feel free to forward email to us. My name is Diogo Oliveira, but you can forward email to any of us. Thank you very much.